everyone, welcome to YourPedia. Welcome to our HPCL question series. So this particular video is for instrumentation engineers who are preparing for HPCL examination. In HPCL examination, controls for instrumentation engineers, control systems is one of the very important subject. You can find a very good number of questions from control systems. So I am going to discuss the questions, 20 good questions for HPCL instrumentation guys in this video. Let's enter into our questions series, right? Yeah, the very first question is, if a system is described by the differential equation 5 into dy by dt plus 10 into y of t is equal to 2x of t, the impulse response of the system will be, see, I will tell you very simply, impulse response means, solution here I am writing, impulse response is equal to inverse Laplace of transfer function. In fact, let's find the transfer function from that one. How to find the transfer function? Transfer function means which is in which domain? It is in S domain. Apply Laplace transform or to this given equation. This equation is the governing equation of the system. So 5 into S into y of s, one derivative will give 1s, we know, plus 10 into y of s is equal to 2 into x of s. What is transfer function? Laplace transform of output y of s by Laplace transform of input x of s is equal to 2 by 5s plus 10. 2 by 5s plus 10. Now, if I apply inverse Laplace to that, I am going to get impulse response, in fact unit impulse response. That impulse response is equal to, yes, if I take 5 common, yeah, 2 by 5 into e power minus 2t into u of t. See, once if you want to understand or you want to prepare control systems, the knowledge of Laplace, inverse Laplace and partial fractions, these are very important. Okay, the answer is 2 by 5 into e power minus 2t into u of t. Choice B is the perfect answer. Choice B is the perfect answer. Let's go to the next question. System in which the output has no effect on the control action are called as, I repeat the statement, systems in which the output has no effect on the control action are called as open loop control systems. I'll draw here. See, I'm taking one open loop system here. There is a controller, this is controller, this is the system, this is system or plant. System, or it is also called as plant. Here this is the output and this is the input. The output what we are getting here is not having any control action over the control signal which is getting generated here. Yes, this is, that particular signal is called as control signal, right? But in open loop, this is open loop. But if the same, if I make it as closed loop, if I make it as closed loop this way, this is plus minus, the output I am feeding back. Now this control signal which is generated is going to depend on both input as well as this output, right? That is the difference between open loop and closed loop. The only difference between open loop and closed loop is in open loop control system, the control signal generated is not going to depend on the output, actual output. But here in closed loop control system, the control signal that generated is going to depend on both input as well as output, right? Let's go to the next question now. Yeah. Determine the damping ratio and natural frequency for a second order control system defined by the following differential equation. See, whenever a differential equation is given, immediately you have to apply Laplace on both sides and you have to get its transfer function. Once we have transfer function, whatnot, everything we can do. If I apply Laplace transform, this is 4s square into c of s plus 8s into c of s plus 16 c of s is equal to 16 into 1 by s. But I keep it as u of s only. Because see, u of s only I keep it. Because I need transfer function. I don't want the output here. I need transfer function. What is transfer function? Laplace transform of output by Laplace transform of input. If I put here 1 by s, some people will simplify it. They are going to get equation in terms of s cube. For s cube, no damping ratio we define in this particular topic, right? So that's why I keep it as u of s only, where u of s is equal to 1 by s, right? Now c of s, if I take common, what I have, 4s square plus 8s plus 16 is equal to 16 into u of s. Now what is transfer function? Laplace transform of output C of S by Laplace transform of input is U of S. U of S is equal to 16 by 4s square plus 8s plus 16. 4 by s square plus 2s plus 16. Now compare this denominator equation with standard second order characteristic equation. Just I am doing that here. Observe. See, I am comparing what is standard second order characteristic equation. S square plus 2 zeta omega ns plus omega n square is a standard characteristic equation that is equal to s square plus, what is the equation we got? S square plus 2s plus 16. S square plus 2s plus 16. From this one, if you compare, in fact, as it is equation, we have to make that equal to 0. If you compare, omega n is equal to 4. See, I'll write it completely. Omega n square is equal to 16. If you simplify that, omega n is equal to plus or minus 4 radians per second. Here one important and simple point I want to tell you that frequency is always positive. Frequency means the number of cycles per second. So never it is negative. Frequency is always positive. Remember one thing, frequency is always positive and real. Never imaginary frequency will exist. Frequency is always positive and real. Therefore, omega n is equal to plus radians per second is the answer. Sometimes in the option he may give plus or minus 4. Some people will tick, sir, mathematically plus or minus 4 both are correct, but we are engineers, not just mathematics students, right? The difference between engineers and mathematicians is just mathematicians will study it as a subject, we engineers will apply mathematics in engineering, right? Yeah. Now, what is another he asked? Damping ratio or damping factor. So what he asked? Determine the damping ratio. Damping ratio means zeta. Now compare 2 zeta omega n is equal to 2 here. That implies 2 zeta omega n is 4 here. Omega n is 4 here, that is equal to 2. This 2 gone. So zeta is equal to 1 by 4, that is equal to 0.25. You know, damping ratio zeta is not going to have any units. It's a unitless quantity. Right? Check the calculation once again. 2 zeta omega n is equal to 2. Yes. 2 gone. Zeta is equal to 1 by omega n is equal to 4. 1 by 4 is 0.25. See the option which one is correct. 0.25 and 2. 0.25 and 4, sorry. 0.25 and 4. Yeah, zeta is 0.25 and omega n is 4. Right? Option C suits very well for the given question. Let's go to the next question. The unit step response of a network is 1 minus e power minus alpha t. See, understand what is he given. Unit step response means what is the input he given? Input r of t is equal to u of t. See, step response means input is step. Ramp response means input is ramp. Parabolic response means input is parabolic, right? And the output what he got or what he given, that is 1 minus e power minus alpha t. I put it as here into u of t anyhow because all this action is going to happen after t is equal to 0. From t is equal to 0 only. Before t is equal to 0, nothing is there. Initial conditions are 0. Now what is asking? What is the impulse response? See, two ways. Impulse response is equal to derivative of step response. So this is step response. Derivative of step response. So impulse response is equal to derivative of 1 is 0 minus of minus alpha into e power minus alpha t, that is equal to alpha into e power minus alpha t is one answer. Alpha into e power minus alpha t, choice A. Another way is, I told you previously in the very first question, that is impulse response is equal to inverse Laplace of transfer function. So from this data I will find the transfer function. Yeah, what is transfer function? Transfer function is equal to Laplace transform of output 1 minus s by 1 by s plus alpha by 1 by s. So I need not to put here, directly I am applying Laplace. Transfer function is equal to Laplace transform of output. My output is 1 by s minus 1 by s plus alpha by 1 by s, that is equal to s plus alpha minus s by s into s plus alpha by into 1 by s. In fact, into 1 by s will become this s is gone, this is gone. So alpha by s plus alpha by s plus alpha. So transfer function I got it as alpha by s plus alpha, then impulse response is equal to inverse Laplace of this one, therefore alpha into e power minus alpha t into u of t. Anyhow u of t value is 1, choice A suits well. See, with both the methods you have to get the same answer. Just for your convenience purpose I am teaching two methods here. Any one of the method you can pick it up, right? Let's go to the next question. The transfer function of the system shown in figure is very simple question. See, in two ways you can do. Either you can apply Mason's gain formula or directly you can do with help of a block diagram algebra. Both the methods I will do. So what is this one? This is RG1, R of S, that S I am not writing. This is what? RG2. Why this is RG2? If this is R, this is also R, this is also R, right? Now see here our block diagram algebra is going to be somewhat complicated. Why? Because I have to write many equations. I'll go with I can say like Mason's gain formula only. I'll go with the Mason's gain formula only, okay? Because here again this is C, this is C, this is C, here C is coming plus C, so this one will be this plus this. That way also we can do. First let's do with Mason's gain formula. What is C by R? How many forward paths are there from input to output? There are two forward paths. First forward path is G1 into delta 1 plus second forward path is minus see G2 into minus 1 into minus 1, that is plus G2 into delta 2. By how many loops are there? How many loops? So this will not form a loop. Why? Because that will not form a loop. Why? Because the arrow is opposite. But I can say this will form a loop. There is one loop that will form a loop. What is the loop gain? 1 minus, I have only one loop, so that loop gain is, yes, it is minus 1. Yes, it is minus 1. Therefore C by R is equal to G1 into delta 1. To this forward path this loop is touching, therefore 1 plus, yeah, let me take up the second forward path also. Yeah, to this second forward path, to this second forward path, that loop is again touching, therefore delta 2 is also 1. So G1 plus G2 by 2, G1 plus G2 by 2. So this is one way. Another way is by using a block diagram algebra. That also I will do, but most of the times I find convenience in the application of Mason's gain formula. Tell me, this is R G1, this is R G2, this is C, this is also C. Now how much is this? This is RG2 minus RG2 plus C. Minus RG2 plus C. Why minus RG2? RG2 is coming to this minus symbol, minus RG2, this is a plus C. Now here C is equal to, here I am writing the equation, C is equal to, what is the incoming from here? RG1, incoming from there is RG1. Now this incoming is coming to the negative. How much I am getting to the negative? Plus C minus RG2. C minus RG2. Right? Yes or not? Now get C this side. I can say like yeah, somewhere we committed any mistake with the plus and minus. Yeah, this is minus of, this is minus. Here I wrote plus. That is what I am wondering why I am not getting the required answer. Yes, this is minus here, minus C minus RG2. So minus of minus C, this will become 2C. 2C is equal to RG1 minus into minus plus RG2 it is. Plus RG2, that implies C by R is equal to G1 plus G2 by 2. G1 plus G2 by 2. In both the ways you have to get the same answer, otherwise one of your answer is wrong. Maybe sometimes both the answers are wrong if you are not following the procedure carefully, right? Let's go to the next question. What is the overall transfer function of the block diagram given below? This is one block diagram. He's asking what is the overall transfer function. Yeah, overall transfer function and transfer function both are same. Now C by R is equal to, yeah, how many forward paths we have? This is the first forward path. What is the forward path gain? G1, G2. G1, G2 into delta 1 plus, how many forward paths are there? I think there are only two forward paths. This is the second forward path, that's all. That is the second forward path. There is no other path. So second forward path is G1, this is also G1 into G2. That is also G1 into G2. Or this is G1, this is G2, this is also G1. Then how come G3 that fellow is having? Maybe 1 is G2, right? This is G1, this is G2, this is also G1 he mentioned. Now in all the options he is having G3, Therefore, some mistake in the question itself, yeah, we are least bothered about the options, right? So this is the first forward path, one forward path. I wrote forward path gain G1 G2 into delta 1. Second forward path is this one, so this is plus, this is also plus, everything it is encountering only plus. Therefore I can write this way. Let me take this one as G2, this one as G3, no, G1 G2 G3, so G1 G2 G1 G3, G1 G2, okay, least bothered about options ma. Yeah, let's write G1 into G2 is the second one also. G1 into G2 is the second one, that is delta 2 by delta. Delta is 1 minus, how many loops are there? 1 minus sum of all the individual loop gains plus sum of product of 2 non-touching loop gains minus sum of product of 3 non-touching loop gains. That's how, in that way we have to do. How many loops are there? First of all, this is not a loop because you have to trial opposite to the arrow. Now this is a loop. In this loop, I am encountering minus here, Only one loop I have, that is minus G2H1, minus of G2H1, the only one loop, minus of, okay, I think he taken this one as G3, this is G3, yeah, G1 G3, yes, G1 G2, yeah, minus G3H1. Now to this forward path, this loop is touching, therefore delta 1 is 1. To this forward path, this loop is touching, delta 2 is also 1. Finding delta 1, delta 2 is very easy, but one must have clarity about delta 1 and delta 2. Delta 1, delta 2, delta 3 are same as that of delta after removing the loops which are touching to the particular forward path. Suppose if you are finding delta 2, 2 stands for second forward path. You choose the second forward path first. Choose the first forward path, second forward path. You remove all the loops which are touching to that second forward path. After that you apply the formula of delta, then what you are getting, that is called as delta 2, right? Now C by R is equal to G1 G3 plus G1 G2 by 1 plus G3H1, 1 plus G3H1. So G1 G2 plus G1 G3 plus G1 G3 by G1 G2 plus G1 G3 by 1 plus G3H1. So this is matching, but G1 G2 plus G2 G3, G1 G2 plus G1 G2, fine. Let's least bothered about the option. There is something missing in the question, means that G1 G2 G3 place is mismanaged, but this is the answer for what I taken, G1 G3 G1 H1. For that, this is I can say the perfect answer. Let's go to the next question. The sensitivity of open loop and closed loop systems are respectively. Now he is taking a general system. The general system is this one. Yeah, this is G, negative feedback is taken, and this is H, so this is R, this is C. Sensitivity of transfer function with respect to G in this one is, yeah, the system sensitivity of open loop and closed loop systems are respectively. See, this is closed loop system. If I am taking open loop system, see, for open loop system, the sensitivity of transfer function with respect to G is equal to 1. Okay, with respect to this closed path, it is 1 by 1 plus GH. You may be wondering, sir, how you got that value? Let me do. In very simple way, I'm going to do. Okay, please do understand, all of you, the formula of sensitivity. Then it is very easy. Calculation part I leave it to you. Okay, only formula part I will be taking. Sensitivity of anything with respect to any variable is equal to, the formula is dou t by t. Yes, yeah, just a minute. Dou t by t by dou g by g, that is dou t by dou g into g by t. Yeah, if it is an open loop system, I have only G, no H, nothing. This is R, this is C. This is R, this is C. See, he asked about open loop system, right? Open loop and closed loop systems. Yes. Yeah. Now Where is transfer function? T is the transfer function. What is T? T is equal to C by R is equal to G. Now dou or T is G by dou G into G by G. This got cancelled. Derivative of G with respect to G will be 1. Therefore it is 1. Same way, if you are taking closed loop transfer function, T is what? G by 1 plus GH. The transfer function of this particular block diagram is G by 1 plus GH. You can apply Masson's gain formula. Just now I taught previously. M1 delta 1 plus M2 delta 2 and so on by delta, where M1, M2, M3 are forward path gains. Delta is 1 minus sum of all the individual loop gains plus sum of product of 2 non-touching loop gains minus sum of product of 3 non-touching loop gains and so on. It continues. Or you can use the block diagram algebra also to find its transfer function with respect to G. What is the formula? Dou by dou G of T. T is what? G by 1 plus GH into G by T is G by 1 plus GH. This G gone. So sensitivity of a transfer function T with respect to G is equal to dou by, means I will simplify it. Yeah, G, see 1 plus GH into 1 plus GH into, what is the derivative of G with respect to G? It is 1 minus, you know the formula for derivative of U by V, minus, see G into this one derivative is 0, GH derivative is H by 1 plus GH whole square into 1 by 1 plus GH. So this 1 plus GH, this 1 plus GH gone, this GH gone. So you are left with 1 by 1 plus GH. The answer is 1 by 1 plus GH. We proved it. Answer is 1 and 1 by 1 plus GH. Right? See, he given open loop and closed loop system respectively. Some people in hurry, they may tick for 1 by 1 plus GH and 1. No, the answer is 1 and 1 by 1 plus GH. Right? Let's go to the next question. What does the transfer function of a system describe for the system? Only 0 input response, only 0 state response, both 0 input and 0 state response, neither 0 input response nor 0 state response. This is very important question. Transfer function is defined only if initial conditions are 0, means previous state, initial conditions are not considered. Transfer function will give only 0, I can say, state response. It is going to have input response, right? Yeah, only 0 input response, no, only 0 state response, yes. It is going to give if and only if a previous state of the system is 0, otherwise transfer function is not defined. There are few points about transfer function. It is defined only for LTI systems, for single input single output systems, and with 0 initial conditions. See, 0 input response means if input is 0, who has to give the output? Initial conditions. Means this is saying that it is going to give the response due to initial conditions. Absolutely wrong. Both 0 input and 0 state response, absolutely wrong. Neither 0, absolutely wrong. Only 0 state response. State of the system should be 0. Previous state, initial state means previous condition, must be 0, right? Yeah, let's go to the next question. Find the transfer function Vc of S by V of S for the circuit. Yeah, he given Vc here. First of all, if you want to find transfer function, entire thing must be in S domain. Total circuit must be in S domain. Circuit or system must be in S domain. So this is L will be written as Ls in ohms, R will be written as R only in ohms, but capacitance can be written as 1 by Cs. It is also in ohms. This is Vc of S plus minus, this is Vc of S, and this is V of S. Transfer function is, so according to voltage, I can say division formula, according to voltage division formula, output voltage Vc of S is equal to input voltage into output impedance plus total impedance, So Vc of S by Va of S is equal to 1 by yes LCS square plus SCR, LCS square plus SCR plus 1. So option B, 1 by LCS square plus RCS plus 1. Let's go to the next question. The transfer function of a system is G of S is equal to S plus 1 by S square plus 5S plus 10. What is the order of the system? One of the very important concept, order of the system. Yeah, order of a system means it is the number of independent energy storage elements which are present in the system, or the highest power of S in the transfer function, or highest number of poles or zeros, whichever is greater, right? It is the number of it is the number of independent energy storage elements. Energy storage elements in a system or number of poles are zeros, whichever is greater. Yes, which is greater. Yeah, here there are 2 poles, 1 0, therefore I have to consider poles, therefore order is 2. That much simple it is. Let's go to the next question. The impedance Z of S is equal to V of S by I of S for a capacitor. See, capacitor in time domain, yes, this is C in farads, this is Vc of t, this is Ic of t, right? Now, if I apply Laplace, see what is the voltage across a capacitor formula? Vc of t is equal to 1 by C integral I of t dt. So Vc of S is equal to 1 by C into integration is 1 by S into I of t is I of S. So Vc of S is equal to 1 by Cs into I of S. This is in volts. Now this is in amps. Then definitely the units of this 1 by Cs must be in ohms. That's all. So 1 by Cs, that is impedance. Yes, capacitance in S domain is represented with 1 by Cs, which is having units of ohms. Let's go to the next question. If the input and output of a system is related by the following differentiation, then find its transfer function. Just I told you now itself, apply Laplace on both sides, take Laplace transform of output by Laplace transform of input, you are going to get the transfer function. Apply it, S square into Y of S plus S 3 into, plus 3 into S into Y of S plus 2 into Y of S is equal to U of S plus S into U of S. Why S? One derivative will give one S term. Now if I take Y of S common, S square plus 3S plus 2 is equal to, if I take U of S common, this is S plus 1. So Y of S by U of S is equal to S plus 1 by S square plus 3S plus 2. S plus 1 by S square plus S plus 1 by S square plus 3S plus 2. Option A is the answer. Option A is the answer, right? Let's go to the next question. Consider the system in the figure shown. The input to the system is R of S and the output of the system is C of S. The system is of type. Type means it is the number of open loop poles which are present at the origin. So I have to get its open loop transfer function. What is open loop transfer function? That is equal to 1 by S plus 2 into 1 by S into 3, that is equal to 3 by S into S plus 2. Open loop transfer function. Note, let me write a note point here. Note that is OLTF is equal to G of S, forward path transfer function, G of S. What is that? Into H of S. H of S is feedback path transfer function. G of S is 1 by S plus 2 into 1 by S. H of S is 3. So how many poles are there at origin? Now if you see this particular S power 1 or S, 1 pole at origin, therefore it is of type 1. So type means, note, another note I am writing here, type is number of open loop poles which are present at the origin, right? Which are present at the origin. Let's go to the next question. In RC series circuit, the transfer function I of S by V of S equal to, series RC is asking. Series RC, this is R in ohms. Just now itself I told you that capacitor in S domain will be represented as 1 by Cs in ohms. Let's take it as V of S voltage. Now current in the circuit is I of S. Simply current I of S is equal to V of S voltage divided by impedance, that is R plus 1 by Cs. So I of S by V of S is equal to SC by SCR plus 1. So SC by how much it is? SC by SCR plus 1. Choice is A. That much easy it is. Let's go to the next question. Find the transfer function E of S by R of S for the system. So here this is the output what he is taking here. How many forward paths are there? Only one forward path. So E of S by R of S is equal to one forward path gain is 1 into delta 1 by delta is 1 minus how many loops it is having? Only one loop. That loop is touching to that forward path, therefore delta 1 is 1. Delta 1 is 1 and the loop gain is a minus of G of S into H of S. Therefore E of S by R of S is equal to 1 by 1 plus G of S into H of S. 1 by 1 plus G of S into H of S. Choice A is the answer. Just application of Mason's gain formula. If you know how to apply Mason's gain formula, job is done. Right? Let's go to the next question. The transfer function of the circuit given below is, the transfer function means V naught of S is equal to, I told you in S domain capacitance will be represented as 1 by CS in ohms, and this is R in ohms. Yes, this is V naught of S, this is V naught of S, this is VA of S. So V naught of S output voltage is equal to input voltage into output impedance by total impedance. So V naught of S by VA of S is equal to SCR by SCR plus 1. So SRC by 1 plus SRC. Voltage division applied. Output voltage is equal to input voltage into output impedance by total impedance. Voltage division, that's all. Let's go to the next question. The transfer function of a system has a 0 at -1 and a pole at -2. Okay, so transfer function is equal to some k into, it is having a 0 at -1, therefore it will be S plus 1, and a pole at -2, right? And gain factor of 2, the unit step response is, he is saying that this gain factor k is 2. Then he is asking about unit step response. See, very simply we can do, I can do that. See, transfer function is equal to Y of S by R of S, where R of S is equal to what? R of S is equal to 1 by S. Why? Because input is what? He is saying unit step response. Unit step is the input. Unit step means R of T is equal to U of T. Yes, R of T is equal to U of T. Then if you apply its Laplace, R of S is equal to, you are going to get it as 1 by S. So now output Y of S is equal to 1 by S into K is 2 into S plus 1 by S plus 2. S plus 1 by S plus 2. Now Y of S is equal to 2, you can keep it outside, and S plus 1 by S into S plus 2. Apply partial fractions. Y of S is equal to, this is S, this is S plus 2. Put S is equal to 0, you are going to get it as 2 by 2, it is 1. Put S is equal to -2, so you are going to get it as -2 plus 1 is, this particular value is -1, and this is -2, therefore it is 2, 2 by 2, again it is -1. Now Y of T is equal to 1 by S U of T minus e power minus 2t, the whole into U of T. So 1 minus e power minus 2t is the answer. So 1 minus e power minus 2t, option B is the answer for the given question, right? See, if you know the concept this way easily with the, see, I wrote partial fractions here by inspection. I did not consider any A, B, C and all, right? So that is called as direct inspection method of finding partial fractions, right? Let's go to the next question. For the given signal flow diagram, the transfer function is, for this one Mason's gain formula is not applicable for this question, right? Because for the application of Mason's gain formula, input node must be defined, output node must be defined. What is input node? The node which is having only outgoing branch is called as input node, but this particular node R is having input as well as output. It is having input as well as output, therefore R is not input node. Now if Mason's gain formula is not applicable, what is the procedure? Algebra, signal flow graph algebra. Now what is the equation for C? C is equal to, this is C is equal to minus H1 into C, because C is incoming to itself with the help of C, plus R into, let's take this one as 1. Let's take this one as 1. R into 1. right? Now you take C that side, C into 1 plus H1 is equal to R. That implies C by R is equal to 1 by 1 plus H1, 1 by 1 plus H1. Okay, here it is I can say like it is y minus H1. If it is minus, so it is plus only. Sorry, I took wrong values. Just a minute. I'll erase it. I'll do the values I took in wrong way, ma. That's why our answer is not matching. Here I thought it is minus H1. No, it is plus only. If it is plus only, see, we all know that the value of a node is affected by only its incoming branches. It is unaffected by its outgoing branches. If you see, otherwise I'll cross it, I do it again here. Now C is equal to this node value. C is equal to this node itself is incoming to the same node with help of H1. Therefore that is CH1 plus another incoming is some 1 into this R. Yeah, incoming node into branch gain, yeah, that is R. So C into 1 minus H1 is equal to R. Therefore C by R is equal to 1 by 1 minus H1. Option C suits very well for the given question. Let's go to the next question. Signal flow graph is easy to obtain the transfer function. The main purpose of signal flow graph and block diagram is to find the transfer function of the system. Stability of the system, no. Transfer function of the system, yes. Not controllability, not observability, right? Yeah. Let's go to the next question. The transfer function for the system shown in figure is the same question number of times it was asked. You see why I taken the same question which was asked number of times. See, that much important to have the knowledge of transfer function, how to find it, how easily we can find it. See, RC circuit, again it is R in ohms. Yes, this is 1 by CS in ohms. You know that capacitance in S domain will be represented as 1 by CS and its units are ohms. This is EI of S, this is EI of S, this is E naught of S. Output voltage E naught of S is equal to EI of S into 1 by CS by R plus 1 by CS. So E naught by EI is the transfer function, that is 1 by SCR or 1 by RCS plus 1. 1 by RCS plus 1. Choice is A. Let's go to the next question. Yeah, I think with this we are done with the all 20 questions what I picked for this HPCL examination. See, the important point you have to understand here is the level of HPCL examination in instrumentation paper from control systems are of this level only, and I can say somewhat less than this level. I covered somewhat of some delta X% above the level of instrumentation paper in HPCL. See, here we at YourPedia will teach in examination success oriented way. Okay, YourPedia started its module for this HPCL instrumentation and electrical preparation also. Join your hands with YourPedia and achieve your success. So this way every week networks and controls in this way I'm going to take up, and the next week I'm going to take up some 20 good questions from network analysis. So this way all corners of both the subjects I will be covering. Thank you.